All right, so this is going to be part of your Wednesday independent work for the day. We're going to take the notes for lesson 7, which was called Percent Machines. The notes are in your Desmos workbook on page 50. So copy these notes with me, and then I believe the other part of your independent work for the day will be to do a Desmos activity called Dueling Discounts Part 2. You might remember Dueling Discounts was the one where you were presented with a $20 off coupon and a 20% off coupon, and then a bunch of different products like a car and a fidget spinner, and you had to determine which was the better coupon to use in each of those purchases. This is an extension of that activity, but this time the discounts aren't as easy to determine, or like the best discount isn't as easy to determine, and the products, the prices of the products are such that the challenge is a little bit more. And so I would like it if you actually calculated the discount for each coupon, rather than just sort of guessing or saying, oh, I know, I can just tell. I think both me and Mr. Wong would like to see you actually calculate all of the discounts in the activity to make a very precise decision in each one. All right, but let's do these notes first. So it says number 1 here, a number went into this machine and 46 came out. And then it's kind of hard to see on my screen, but you have the same book. It says here that this machine increases numbers by 15%. And it's our job to figure out what number originally went in here. And so when you put a number into these percent machines, the number that goes in is like your original or your whole number. And what comes out is your new number, or what we sometimes refer to as the part. And I see that this percent machine is increasing whatever you put in there by 15%. And what you were supposed to, well, one of the things you were supposed to learn in doing this Desmos activity called percent machines is that an incorrect strategy in handling these types of questions would be to think, oh, okay, if the original number went in here and was increased by 15% and we got 46, then I should be able to just decrease 46 by 15% and get back to the original number. It doesn't work that way. And one explanation for the reason why that is let's say we call this unknown number here our unknown original number, x, and they have a question mark in the box. You could represent it with that too, but I'm going to put an x here. When x is increased by 15%, that 15% is 15% of x, whatever that number is. Maybe it's 40, maybe it's 38, maybe it's 42. I don't know. I actually haven't done this question yet. But it's 15% of that. And if you were to take 46 and reduce it by 15%, that 15% would be a different number, right? That'd be 15% of 46, which would be bigger than 15% of whatever x is, because we know x has to be smaller than 46. I'm guessing it's about 38 or 39. And so if you took 15% off of 46, you would wind up with a number that is smaller than your original. So you have to be really careful about, where are my percents coming from in each question? They're always coming from whatever is considered your original or whole or starting point number in the question. And so when you're given the new amount, like after the percent increase or decrease, you can't take your percent from that unless you do it in sort of a careful way of what the percent is. And what we do is we look at remaining percents rather than looking at the percent change, right? I'm going to refer to this number as the percent change, whether it's going up or down. It's a percent change. We can't really use this number in these situations. Instead, what we look for is that remaining percent, or remaining percent, new percent. I don't know. There's different ways. Total percent. There's different things you can call this. So let's call it the total percent in this case. Well, the total percent in this case is going to be our original 100% that we started with, right? Your original number is always 100%. And then we increased it by 15%, and that gave us 115%. So 46, you don't necessarily, well, yeah, you should write this next sentence and I'm right. 46 is 115% of the original number. That's the number we want to use to figure out what that original number was. Because if you're in my class, you know that we've been doing this, these formulas where remember whole and original are the same, new and part are the same. The whole number equals the part that you have divided by the percent that it represents. And so now we could find this whole or original, these mean the same thing, this original number by taking the part, which is this 46, and dividing it by 115%. We don't use 115 though, right? We take the decimal point, 115%. We take this decimal point, we move it 2 spaces, it equals 1.15. So we're going to do 46 divided by 1.15. And that's going to get us our result. So let me see what that equals. I didn't do this question ahead of time, so I don't know what it is. 46 divided by 1.15 equals 40. That's kind of close. I think I said 38. I think I said 40, and that's wrong with 2. So another way you could think of this, if you're thinking about it sort of the way that Mr. Wong likes to show it, is thinking of it as a proportional relationship, where your original number is always your sort of like your x value, and your new number is sort of like your y value. And we don't know what this is, but we know that our new number is 46. And so we know that just like in a proportional relationship, if you have your y value and you're trying to find an x value, you got to divide to get back to that, right? You got to divide by your k. What's really important here, though, is to just know what is my k in this case. It's not the 15%. It's not the percent change up or down. It's this remaining or total or new percent over here, where we say, okay, if it went up by 15%, then we have a new total of 115%. So your k in this case is going to be 115%, which we represent as 1.15. Let's move on. That's the big idea of this lesson, though, and those questions like that are tricky. All right, number 2 says 50 went into a different machine and 46.5 came out. What percent increase or decrease did the machine use? Okay, so this time, instead of us trying to find the original number or find the new number, we have to find this percent change, okay? And this is going to be a percent decrease, right? Because we put in the number 50 as our original number, and it came out of 46.5. So this must be a decrease machine. So to find a percent decrease, what we should do is take our original number and subtract our new number. Really, we're just trying to figure out the difference between them, right? Or how much did the original number go down by? You could probably look at these and say, oh, it went down by 3.5. Maybe you could do that in your head, but let's do it very thoroughly. So I want to do original minus new. And so in this case, that's going to be the 50 minus 46.5 equals 3.5. So the 50 decreased by 3.5. But we don't want to know that. We want to know how much it decreased as a percent. As a percent of what? Well, always as a percent of our original number. It's always as a percent of our original number. And so we want to take this new part and divide it by our original whole, right? Percent equals part divided by whole. And so we take the difference and we divide by the original. And that equals 3.5 divided by 50. So we're going to get 3.5 as a percent of 50, basically, right? So let's see here, 3.5 divided by 50. I think it's going to be 7, because if I was dividing by 100 here, I get 3.5. 50 is half of 100, so it should turn out double. Wait, what? What did I do? I did something wrong. I pressed something wrong. 3.5. I must hit times instead of divide. Yep, 0.07. Move the decimal point over 2 spaces. Boop, boop. It's 7%. So equals 0.07, which equals 7%. So this was a 7% decrease. There's a kind of a very fancy, well, not really super fancy, but like more mathematical or succinct way of writing this formula. And so I'm going to write it over here. Formula for percent change. Let me think about the way I want to write this just for a second. Yeah, so I was going to write it a certain way, but actually I think there's like an easier or clearer or nicer way to write it. So whenever you're given one of these types of questions, like question 2, you can take the bigger number and subtract the smaller number. All right, so in this case, there was the 50 and the 46.5, and we did 50 minus 46.5. It just happened in this case that the 50 was the original number and the 46.5 was the new. But if you had a different question where it was the other way around, where the original number was the smaller number and the new number was the bigger number, so in other words, it was a percent increase question rather than a percent decrease, it wouldn't really change anything. You should still just take the bigger minus the smaller. You're just trying to figure out the difference between them. How much did it change? And then in the end, you always want to represent that difference, right? Whatever you get when you subtract, as a percent of the original number. We're always taking percents of our original or our whole number, never of the new or the part number. And so whatever you get when you subtract, just divide it by whatever the original or the whole number is in that case. That's all there is to it. And that's all we did here. We did bigger minus smaller. We figured out that it changed by 3.5. And then we divided by our original 50 and figured out it was a 7% decrease in that one. All right, lastly, number 3. What are some important things to remember? You know, hold on. So this formula over here, I feel like is really important and useful, and you're probably going to want to use it on a quiz or a test. And so, oh, I'm off the screen. I really feel like you should circle this and like make it super obvious that like this is how you do a question like number 2, so that if you're coming back on a quiz or a test and you get a question like number 2, you look over here and you should be able to just follow these instructions. Take the bigger number minus the smaller number and then divide by the original. All right. Number 3, what are some important things to remember about figuring out the original value given the new value and a percent increase and decrease? Okay, so this is essentially saying how to do question 1. Right, these types of questions is what this is saying, because question 1 was one where we were given the new value, the percent increase, and it was our job to find the original. That's what they're describing in number 3. Important things to remember is that the percent change always comes from the original, never the new number. Because of this, we use the total or remaining let me zoom in a little bit. Sorry, that's so small there. That says remaining percent after the increase or decrease, sorry. And so in this case, in the example that we did up here, it was 115%, right? Original 100% plus the new 15%. And then lastly, if it's a question just like number one, it's pretty much always going to be solve by division. Whether you like to think of it as, the whole equals part divided by percent, or you like to think of it as, this situation, where, you have your whole and your new, and it's a question mark over here, but you have some new value. I don't know, 42, the answer to all questions, right? Divide by K. Whichever way those ways you like to think about it. In the end, it's just this idea of understanding that you're going to wind up dividing to solve that type of question. All right. Yeah. Dueling discounts part 2 is the rest of your independent work for the day, and we'll see you tomorrow.